Okay, Bismillah ar-Rahman ar-Rahim. We'll start now the video. This video where we'll do more examples. Let me explain what we have in this section. I think this slide will explain it. There are methods to find e to the power delta t. If A is diagonal matrix, if A is nilpotent, then there is a way. If A equal diagonal plus nilpotent, also there is a way. If you know the fundamental matrix, then also you can find e to the power 80. And how that will help? That will help to solve the system. If I know the fundamental matrix, then it's fundamental matrix times the constant matrix. If I know the exponential matrix, then it's e to the power 80 times c. If I have initial condition, then this will be the how to find the solution. And in case of e to the power delta t, it will be easier. Okay. Another example is how to find e to the power 80. Now let me solve this. First, you need to check, is this nilpotent or not? Multiply this by this. It seems to me it's nilpotent. That will be what? 1 minus 1, 0, minus 1 plus 1, 0, 1 minus 1, 0. Yeah, so it is a nilpotent matrix. Okay, so I'll find a square. That will be 1 minus 1 minus 1. How I solve the system? Yeah, let me just talk about that first, and then I will do the calculation. I can solve it through two ways, either two fundamental matrix. We need to find eigenvalues, eigenvectors, blah, blah, blah. Yeah, then find the solutions. It depends in the case of the eigenvalues, real, distinct, not real, repeated, all of these things. Or another way, through the exponential matrix. That's it. I find the exponential matrix, then the solution will be e to the power 80 times c. Here I find the fundamental, then the solution 5t times c. That's what we need to do. In this case, I can find e to the power 80 easier than finding the eigenvalues, eigenvectors, and do all of this calculation. Where I notice a square will be what? 1 minus 1, 1 minus 1 times itself. That give me what? 1 minus 1, 0, minus 1 plus 1, 0, 1 minus 1, 0, minus 1 plus 1, 0. So e to the power 80, actually it will be I plus 80 plus 0. So it will be what? 1, 0, 0, 1 plus the A matrix times the times t, and that will be 1 plus t minus t, 1 minus t. So it's my solution, e to the power 80 times c, times c1, c2, which can be written as c1, 1 plus t minus c2t, okay, and c1t plus 1 minus t plus t2, 1 minus t. Yeah. So that will be the solution. Instead of finding eigenvalues, eigenvectors, do all of these calculations, now we find it quickly. Another problem, now this is 3 by 3, which will make our calculation more difficult if you want to do it through eigenvalues and eigenvectors. I think so, yeah. So what I will do, I'll try to find e to the power 80. I notice first a is what? A is diagonal plus nilpotent. Yeah. Since A is this diagonal matrix, is diagonal, yeah. One of diagonal is 0, it's okay. Diagonal means off diagonal is 0, the rest can be any value, which is the diagonal elements. Plus n, which is 0, 0, 0, 10, 0, 0, 20, 50, 0. Yeah. So this is d plus n. This is diagonal, and this is nilpotent. You can check this. N square, I think it will be with n cubed. Let me check. The number seems to be strange numbers. Okay. 0, 0, 0, 10, 0, 0, 20, 50, 0. That give me what? 0 first row is 0, 0, 0. This is 10 times 0, 0. Is 0, 0, 0. Second row, 10 times 0. I need only the first. That will be 0, 0. Third row times the first, that will be 500. Am I right? 20 times 0, 50 times 10, plus 0. Now for the rest, it will be 0, 0. Yeah. Let me see what will happen. Is it 500? This is the third row. Yeah, 2050 times the 10. Yeah. Okay. Now n cubed will be 0, 0, 0. Yeah. Times what? Times the a times the n itself. That I have 0, 0, 0. First row is 0, so 0, 0, 0. This is will be 0, 0, 0. So my e to the power dt, e to the power at will be e to the power dt times e to the power nt. Now, let me find here e to the power dt, just a diagonal, e to the power 5t, 0, 0, 0, e to the power 5t, 0, 0, 0, e to the power 0, which is 1. Okay. E to the power nt will be what? I plus nt plus n squared t squared over 2 factorial plus 0. Because n cube will be 0 and the rest will be 0. So that will be 1, 0, 0, 0, 1, 0, 0, 0, 1. N is what? 0, 0, 0, 10, 0, 0, 20, 50, 0 times t plus, what is this? 0, 0, 0, 0, 0, 0, 0, 0, 500, 0, 0 times t squared over 2. Okay. So that will be what? It will be this matrix E5T 0, 0, 0, E5T 0, 0, 0, 1 times what? This one will be what? 1. Yeah, this one I can write it here. 1. Then I have 0, 0. That will be 0. 0, 0, 0. That will be 0. Then I have 0, 10t. 10t. Then I have 1, 0, 0, 0, 1. Then I have 0, 0, 0, 0, 0, 20t plus 500 plus 250 t squared, 500 over 2, which is 250. Okay. I think this should be 250, not 100. Okay. Let us see. Now, the next element, 0, 50t. That's it. All right. Yeah, 0, 50t, and then 0. And the last thing is 100, which is 1. So I plug this here, 100, 10t, 10. This is what 20t plus 250t square, 50t, 1. Okay. Let's see what are we getting. First row times this, it will be E5t. First row times the second will be 0, 0. 0, that will be 10t e5t. Into e5t, okay. The rest, this times second, that will be e5t. Then it will be 0. This times this, it will be 0. Yeah. The third row, that will be 20t plus 250, 20, 250 t square times 1. Since I have e to the power 0 is 1. Okay. That element is 1, is 0, not 5, huh? Yeah. Okay. Then this times that will be 50t, and the last one will be 1. I cannot take anything as a common factor. That would be my answer. Yeah, which is not this. Forget about this. Okay. Use an exponential matrix to solve this initial value problem. I think we did this before. 2, 2, 2. Did we? Yeah, this is the one. I know e to the power t. It will be what? Yeah. So let me use that. So I need the exponential matrix. So we'll find e to the power at first. I notice a is d plus 0, 3, 4. So it's d plus n. Actually, it is 2i plus n. So e to the power dt will be e2t times e to the power nt. And we did that before. Yeah. We did that before. It is 13t for t plus 9t squared. Yeah, instead of wasting time, do it all the time. 13t for t plus 9t squared. Yeah. 0160 001 01 0160 001 times e to the power 2t, huh? Don't forget to have e to the power 2t, something here. Okay. Now, I know if I have the system x prime equal ax, where x at 0 equal x0, then what will be my solution? Solution will be x of t e to the power at times x0. By the way, then we'll do this. So I have e to t times this matrix. Yeah, need to be careful now with the calculation. Times this strange number 19, 29, 39. Okay. So I have what? I have e to t. This is, I can take it as a common factor. I have the first row times that. Yeah, that would be very complicated. Let me write it here. Times what? 19. Oh, 29 times 3 is what? 29, 30 times 3, 90. Minus 3. That is 87. T. Plus, this is 40, 160. Minus 4. Yeah, 156. T. 9 times 39. 360. That's 351 t squared. This is only the first. Yeah, this times this. This is only the first row. The rest I think will be easier. It will be 29. 6 times 39. 6 times 40, 240. Subtract 6. You have what? 234. t, and the last one just 39. So that give me what? 19 plus what? 6 and 7, that would be 3. 1, 13, 14 t plus 351 t squared times e to the power 2t. And here we have 29 plus 234 t times e to the power 2t. And the last one, 39 e to the power 2t. And that is my answer, which is easy. Yeah. You want us to show if I have a matrix in this format, then it will be a nilpotent, which is, they call it, yeah, upper triangular. Okay, just I have the elements in the upper triangle. I mean, diagonal. I mean the upper triangular. I have values non-zero in these values. Okay, so notice case 1. This is a. What will be a square for any alpha? That will be what? 0, 0, 0, 0. So A is nilpotent. Nilpotent, okay. Now, case 2, B, 0, AB, 0, 0, C, 0, 0, 0. Yeah. What will be B square? I think with the cubed, it will become a 0, 0 matrix. Let me do the calculation. That give me what? This times this, that will be 0, 0. This one, 0 times B and A times C, and B times 0. Now this one will be 0, 0, 0, 0, 0, 0. What will be B cubed? It will be 0, 0, AC, 0, 0, 0, 0, 0, 0 times B. Notice I'm doing it for any ABC. You're getting what? 0, second column 0, 0. Yeah, the rest are 0, 0, 0, 0. So very clear, B is nilpotent matrix. Okay. Find e to the power 80 for these matrices. First one is easy one, diagonal matrix. Right away, e to the power 80 will be E2t 0, 0, E3t without doing anything. 2. This is nilpotent, should be. So I'll find A 6, 4 minus 9 minus 6. Is it? No. I don't think it's an nilpotent. Will that make, yeah, it will be what, 36? Seems to be 36 minus 36, 0. 24 minus 24, 0. Interesting. Minus 9 times 6 plus 9 times 9 plus 6 times 9, that will be 0. Minus 36 plus 36, that will be 0. So it's an nilpotent. Good. So it will be e to the power 80. It will be I. So this is a square. It's this. So e to the power 80 will be I plus 80. And that's it. Plus 0. The rest will be 0. So I have the identity plus 80, which is 6, 4 minus 9 minus 6 times t. That give me what? 1 plus 60, 40. That will be minus 90 and 1 minus 60. Yeah, which is this answer. Good. Now let me do more. Yeah. Need to find e to the power dt. First, I have this. A is what? 2I plus this matrix, which is 0, 2, 3, 0, 0, 2, 0, 0, 0, which is in this format. Which is in this format. So it's nilpotent. So it's 2I plus n. I need to check this. So it will be e to the power at. It will be e to the power 2t times e to the power nt as a matrix. Now for n, let me start it here. I'm going to do the two problems. Okay, so let me start it here. N equal what? N equal 0, 2, 3, 0, 0, 2, 0, 0, 0. What will be n square? 0, 2, 3, 0, 0, 2, 0, 0, 0 times itself. What you will get? This give me 0, 0. Then I have 2. First row, third column, 2 times 2, that will be 4. And the rest, I think, are zeros. Yeah. What will be n cubed? It will be n cubed will be 0, 2, 3, n square, which is 0, 0, 4, 0, 0, 0, 0, 0, 0, times n 0, 2, 3, 0, 0, 2, 0, 0, 0. What are we getting? 0, 0, 0, 0, 0, 0. You can't check it. Yeah. So it is e to the power nt. That will be I plus nt plus half plus n square t square over 2 factorial plus 0. That will be the identity plus n, which is 0, 2, 3, 0, 0, 2, 0, 0, 0 times t plus 0, 0. What is it? 4, 0, 0, 0, 0, 0, 0 times t square over 2. That give me what? 1, 2t, 3t, 4 over 2, which is 2t square. Then I have 0, 1, then I have 2t, then I have 0, 0, 1. What will be e to the power at? It will be e2t times e to the power nt, and that e2t times this matrix. Okay. Now part 4. What is a? Is 0 minus 1, 1, 0. Can I do it through the nilpotent? No, it's not nilpotent, not diagonal. It's not nilpotent. You can do it through the expansion, I would say, but a little bit hard. I can do it as a fundamental matrix. So let me find the eigenvalues. A minus lambda I. Let me do it quickly. That will be what? Minus lambda minus 1, 1 lambda minus lambda, I mean, which is lambda square plus 1 equals 0. So lambda equal plus or minus I. Now for lambda equal I, what I will do, I solve the system. Minus I minus 1, 1 minus I times k1, k2 will be 0, 0. So I have what? Minus I K1 minus K2 and K1 minus I K2. These two should be the same. Multiply minus I by the second equation. You will get what? You'll get minus I K1 minus I times minus I is I squared, which is minus 1. So this is correct. So I have K1 I K2. So if I let K2 equal 1, I'm getting K1 equal I. So V1 will be what? I and 1, which is 0, 1 plus I 1, 0. So it will be my solution. X1, yeah, be careful now. I have 0, 1 cosine t minus 1, 0 sine t. And that is what? That will be minus sine t cosine t. And x2 will be what? Oops. X2 will be 1, 0 cosine t plus 0, 1 sine t. And that will be cosine t sine t. So my phi of t will be what? X1, X2, which is minus sine t. Here cosine t. Here cosine t. Sine t. Are we done? No, not yet. Let me give more space. Okay. So now e to the power 80 is 5t times phi inverse at 0. What is 5t? Yeah. It's minus sine, cosine, cosine, sine. Okay, minus sine t, cosine t, cosine t, sine t. What is phi at 0? Phi at 0 will be minus 1. No, 0. Sine 0 is 0. Cosine 0 is 1, 1, 0. So what is phi, determinant of phi at 0? That will be minus 1. What is phi inverse at 0? That will be minus 1 times what? This is interchange, which is making no sense. Nothing. So that will be 0, 1, 1, 0. So this is will be minus sine t cosine t cosine t sine t times 0, 1, 1, 0. That give me what? This times this, that will be cosine t. This times this minus sine t. This times this sine t. This times this cosine t. Which I think this answer. Yeah, cosine minus sine, sine, cosine. Good. Which is this answer. Oh yeah, this two. Okay. Now we'll go to this one. We'll do more to solve the system, more practice problems. Let me try to do this one, then I will stop before I will go to all the exams questions. This is very clear nilpotent. Yeah, because it's in this. Actually, it's a diagonal plus nilpotent. We know this is upper triangular or lower triangular. They are nilpotent. So this one, I can write it as 1 1 0 0 plus 0 1 0 0. Yeah, so it's diagonal plus nilpotent. Yeah. So A is D plus N. Yeah, solve the system through the exponential matrix. It would be easier. So e to the power D is nothing, huh? Yeah, very clear. Actually, I have the same diagonal, so I can take it as AI. You can write it as AI, where A is 1. So it's I plus N. So e to the power AT will be e to the power 1, which is E, huh? Like what we did here. AI, where is it? Yeah. Remember when we talk about these things, we have some formulas. Yeah. AI plus N, e to the power A, T, a to the power A, which is 1, e to the power T times e to the power N. Yeah. So I apply the formula that will be e to the power 1 times T, which is e to the power T times e to the power N as nilpotent matrix. So let me work out this one. N is 0 1 0 0. What will be in the square? Yeah, it is 0 0. This one times this 0 0. So e to the power nt will be I plus at plus 0. So no need to think about the rest. 1 0 0 1. A is what? Not A, N, sorry. I'm using N here. N is 0 1 0 0 times t. So it's 1 t 0 1. That will be my e to the power nt. So e to the power at is e to the power t times this matrix. Now what I want the solution. The solution x of t will be e to the power at times c. So it's what? Et, T 0, at times c1, c2. That will be c1 et plus c2 tet, and I have 0, c2 et. Plus, yeah, no need for the plus minus. C2 e to the power t. Okay, let me do this one, then I will stop. It is 1 1 1 plus 0 1 0 0 0 1 0 0 0. Am I right? Yeah. 1 1 0 0 1 1 0 0 1. So it's diagonal. Plus nilpotent. Actually, it's I plus N. That implies e to the power at et times n nt. What is n? N 0 1 0 0 0 1 0 0 0. N square. Let me see what will happen. I think that will go. Let me check. This times this, that will be 0. First row times second column, that will be 0. Then I need 1 here. No, yeah. And that will be 0, 0, 0, 0, 0, 0. So it is n cubed. N cubed will be 0. I can check it, check. Very clear. Then e to the power nt will be I plus nt plus n square t square over 2 factorial. And that will be the identity n, which is 0 1 0 0 0 1 0 0 0 times t n square 0 0 1 0 0 0 0 0 0 times t squared over 2. Don't forget that. And that give me what? 1, then t squared over 2. Then I have 0. Then I have 1. Then t. Then I have 0, 0, 1. What will be e to the power 80? It will be et and this matrix. What will be my solution? General solution, e to the power 80 times c, where c is what? C1, C2, C3, and that will be what? Yeah, 80, TET, T squared over 2, ET, 0, ET, TET, 0, 0, 1, ET, times C1, C2, C3. Oops. That will be what? First one is complicated. C1 ET plus C2 TET plus C3 T squared over 2 ET. That is not easy. C2 ET plus C3 TET. And this is C3 ET. Yeah. Again, just all the exams questions. So I'll do that in the next videos. Let me stop the recording. Thank you.